Okay, go. Oh! Ah.
Howdy, welcome to another Nonsense Wars production. Today we're going to investigate the efficiency of various gear trains. For this setup, we have a GBC module. It's just a chain lift. That's a pretty typical load for a Lego motor. We have a 9-volt regulator so that we power the motor consistently. The module needs a 1 to 5 reduction to run, so we've put a 40-tooth gear on the input of the module. This is the control setup, so we're just going to drive it directly. And the way we're going to measure the efficiency of the gear trains is we'll measure the speed that the motor runs. If the gear train is less efficient, we expect the motor to run at a lower speed. So before we get started, there's actually a few mold variations on the 8-tooth gear. And I'm not talking about the frictionless 8-tooth gear or the 8-tooth gear with shoulder and reinforced teeth. These are well documented. But on the older 8-tooth gear, there's actually a few different molds. This one's the oldest one. You can tell the interior is a little more rounded and the teeth are a little bit finer. This is probably somewhere in between. The teeth are a little bigger and the mold of the inside has a distinct shoulder. And on what I assume are the latest versions, these teeth are a lot bulkier. Bricklink doesn't distinguish between these variations, and for the purpose of this experiment, we're just going to grab some gears at random out of the bag we have. This is the distribution we got doing that.
We wanted to demonstrate the poor performance of gear trains made of 8-tooth gears, especially 8-tooth gears on axle pins. This setup does not create enough load to really punish poor engineering, but it still illustrates an important point. Bad gear trains get exponentially worse as they get longer. The motor speed starts at around 400 RPM for the base case and only drops to around 360 with a 9-gear setup, 8 of them on axle pins. It drops drastically to 280 with an 11-gear setup, and we actually had to add a beam to prevent stressed gears from coming off. The drivetrain stalls entirely with a 13-gear setup, which we more or less expected. So basically, don't do this. Don't transmit power with 8-tooth gears, especially not on axle pins. Just about anything will work better. 6 16-tooth gears covering the same distance, even on axle pins, runs at practically the baseline speed, and fewer numbers of larger gears should work even better. That being said, the problem actually comes more from the axle pins than the 8-tooth gears. In the stalled train of 13 8-tooth gears, every other gear is shifted in the opposite direction, up, down, etc. As the gears get loaded, the pins bend in their sockets and generate friction. Thus, if we replace all the axle pins with actual axles, the 13 8-tooth gears actually do run at around 360 RPM. The axles themselves don't make much of a difference, but supporting both sides does. That prevents the axles from bending in their sockets, and more torque can go into turning the gears. So the TLDR is 8-tooth gears bad, but axle pins worse. Don't use either of them if you can avoid it. More to come in part 2, So stay tuned for that. On that note, this is the end of the video, so have a nice day.